Hey mathematicians, here are your notes for 8.1. We're going to be talking about multiplying monomials. So quick bell work, fill in the what I think versus what I know right here, then go ahead and unpause the video and we'll get her started. So today's goal, I can identify monomials and multiply them by other monomials. So whatever you put here is fine. I'm going to go ahead and give you my definitions. So a monomial in our case is going to be a number, a variable, or a product of both. So an example of a monomial might be 4, it might be x, or it might be a product. So like 4x would be considered a monomial because it is all one product term. An exponent is obviously the number that we're going to raise our base to. So an exponent, I guess you could put the example here of multiply number by itself that many times. That's what an exponent tells us. So the components of an exponent, I think this one is actually easier if you write the formula. B raised to the p, the components of an exponent are the b base, that's our base number, and then p is going to be our exponent itself. And I just want you to know that the bottom number, the bigger number, is called the base, and p is the exponent. So those are the components we're talking about. And then what does it mean to simplify? Well, very much like our chapter 3, it just means to combine or reduce items. Combine or reduce. So let's use that when we consider this. Jeff, Cody, and Max want to maximize the number of food items they get at McDonald's. They know the price of each food item and how much they have to spend collectively, but not how many items minimizes cost and maximizes food. So if you were with your friends, think about this for a minute. How would you maximize how much food you get with spending the least amount of money? No math involved, just what are you thinking about? So there's a lot of ways to go about this, but in the case above, each food item and its price, each one of those represents a monomial. Remember, a monomial can be either a number or a variable. So example, fries, which cost $1.50, the $1.50 could be multiplied by the number of fries. We don't know how many that is, so F, to determine how much the friends would spend on just that food item. So both the $1.50 and the F are each separate monomials. They're single terms. But then when I multiply them together, they're also a new monomial. So let's take it down a notch to the math behind that. If I give you x squared times x to the 5th, these are each an example of a monomial. But when I multiply them together, they're also a monomial because they're just one term being multiplied. So how do I go about simplifying this? Well, x squared is just x times x. That's what the exponent does. It multiplies whatever number is there that many times. If I multiply that by x to the 5th, that's like multiplying by 5 more x's. When I multiply all these together, I essentially get x times itself 7 different times. So to simplify this monomial, I get x to the 7th. Same thing with the next one. This is all an example of a monomial. And if I split it apart, I have 2 monomials. So if I want to simplify this, I basically have w times itself 3 times w times itself 3 times. When I do this, I have w times itself 6 times. Now if you look here, you should notice something. We should notice a relationship between how many w's we start with and how many we end with. The last one is a little tricky because I have n to the 3rd, m to the 5th. But because these bases are not the same, I can't combine them the same way I did here. I can write out n 3 times and m 5 times, but they're not the same base, so I really can't combine them. And the most simple version of this problem is just how it started. So what did you notice each time? Well, I personally noticed that x to the 7th is x squared times x to the 5th if you add the exponents. And same thing with w raised to the 6th power. When we multiply monomials, we add the exponents. Can we write this pattern as a formula? So the way that I would write this as a formula would be like this. X raised to the m power times x raised to the n power is equal to x raised to the m plus n. And what I did here is I chose the same base with two different exponents and I added them together. So notice x, same base, two different exponents, I added them together. So this is our formula that can help us. Notice this does not work if the bases are different, like we saw in our third example. So let's use that formula to simplify the following. Well, Miss Burry, you added numbers. We didn't talk about numbers. But they work the same way. Because 3 and 5, we can multiply separately. And then multiply by everything else. So I go ahead and I take the numbers out to the front, and I multiply the things with the same base. Because 3 times 5 is the same as 5 times 3, meaning I can do this out of order and still get the right answer. So 3 times 5 is 15, and x to the 6th times x to the 2nd, when I add their exponents, I get x to the 8th. Notice I started with 2 monomials multiplied together. I ended with 1. All right, another one. Here, again, I'm going to take those numbers out front and multiply them separately. And I'm going to go ahead and break up these variables because that's just a lot to look at. I notice I have a to the 3rd times a to the 2nd, and I also have b times b to the 5th. When I multiply these all separately, I get negative 12 a to the 5th because I'm adding those exponents. And then b, remember, just has an exponent of 1. So this would be b to the 6th. When I put it all back together and smush it into one giant product, I get negative 12 a to the 5th times b to the 6th. Now, you don't have to do this each time, but I find it's a helpful step when I'm learning. Let's see one without that step. Here I'm going to multiply the numbers. 2 times 8 is 16. A squared times a raised to the 1 is a to the 3rd. Go ahead and try the last two on your own, and then come back so we can do them together. All right. So you're saying, Miss Burry, this only has one number. What do I multiply it by? Well, remember, there's always an imaginary 1 out in front of any variable we have because there's one of that variable. So 1 times 4 is 4. X squared times x is x to the 3rd because there's only 1 there. And then y times y to the 3rd tells me that there's 4 y's. If you need to write this out as x times y times 4 times x times y times y times y so that you can see why this is the answer, feel free to do that too. Use whatever steps you need to feel confident. Last one, negative 5 times 4, there's no other number, is negative 20. X times x squared is x to the 3rd, and y times y to the 4th is y to the 5th. Just putting those pieces back together like a puzzle. This is how you multiply monomials. Let me know if you have any questions.